I've got a raised hand. Hope it went down.
Ryan, can you hear me?
Yes, I can.
I was wondering how that raise hand button works, and that answers my question. I was actually, because we had several people jump in last minute, from your administrator side, can you automatically set to mute mics, or is that an option available?
I think I can, actually. I didn't,
Just
once I started talking, yeah, I'm going to try it on you for just a second to see if it works. Yep.
I am now unmuted.
Yeah, it looks, yes. So, okay, I can do that. Okay. This is the first real presentation I've used on the Zoom interface. So,
yeah. I like the Zoom interface. We were talking about it. It works well. I had a student log on, and I was like, please, please, please make sure you mute. And, you know. All right, we'll see you in a few minutes. Thank you.
All right, no problem.
Yeah, Ryan, were you doing a mute all when you tried to mute everyone?
Let's see. It may be at the top over here.
Ryan, can you hear me?
Yes, I can. I was looking for the mute all option.
Yeah, under participants, there is a mute all at the bottom.
Oh, there it is. Okay, that's the other window. I wasn't looking at that window. Okay. Gotcha.
So that might help, but I don't know if somebody else joins in after you press the mute all, how that's going to function. We'll just have to test it.
Okay. Yeah, I've got the now both windows, the main Zoom with all the people's names, and then also the participants window now up, so I can see as people come on and off and such. Okay. So yeah, I'll keep an eye on that. Thank you.
Yeah, you're welcome.
If I want to ask a question, should I do it verbally or on the chat?
We'll try it both ways and see how it goes. I'm open to either option. I'm trying to kind of keep an eye on the chat window as we go, but you notice that during that I missed a couple of questions until the very end while I was actually in the presentation. So if it's something that I'm actively talking about and I'm kind of skipping on or seem to be moving on, I'd say jump in and by all means ask the question. Or if you see it in the chat window, say, hey, slow down a second. By all means, let me know.
And then if you ask if there are any questions, I can go ahead and verbalize it then.
Definitely,
Okay.
yes. And I'll keep an eye on this window. If I see raised hands also, I will try to pause and, okay, I see a raised hand, what's going on? And we'll go from there as well.
Oh, raised hand.
You don't have to use that. But if you do that, I will ask about it. I see there's one right now, and I will.
I'm trying to figure out how to even get to that point.
So if you mouse over your name, well, hang on here. I may not have it in the same spot you do.
Oh, maybe this start video button.
Let's see. The video button. If you start that actually starts.
Got it.
Your webcam, and so we can see you. So that's what that does.
Okay. I'm not really seeing you because you're busy doing the...
Well, I don't have my camera on at the moment. I can turn it on here for a minute. Let's see here. I turn it on this one. Oh, that's right.
Ryan, can I jump in?
Yes, you may.
Under the More feature, hi Ryan, I can see you now.
Hi.
I got it. I see.
Under that More feature is the raised hand, and what I wanted to ask is, if when I clicked raised hand earlier, does that come up in your box if you do not have the text dialog open?
It comes up. So I've got both the. Right now, I have. I think probably the view that you're looking at. That's got all the windows for if people have their cameras on.
Yeah.
Yes. And then it comes up in both places.
I was just wondering if, when you're focused on the thing, if people have a question, but you don't have your text dialogue open for the conversation, if we hit the raised hand, does that notify you? Would that be a better way to ask a question?
Yeah,
so
actually.
These are the two windows that I've got. And so there you lowered your hand, or I can lower it for you. We've got a hand raised here. And I think in the panel over here, it's down now, but it also shows up in this panel here. And what I had during the meeting was I had the chat window open and then this window. And so I could see when people come in and are muted or not muted by the symbol here. And then I did not realize I could open up a participant window also like this one. That was when Ray pointed me in that direction. So.
Okay.
Okay, I'm sorry. Where's the raised hand?
Nobody's got one raised right now.
Is that just me doing this?
that can work too. that works for you. But so in mine, I've got a more section. Let's see here. Let's see if I can show this. Yeah, I don't have the right, since I'm presenting, I don't have the option, but I think it's right here in this triple dot, you select that. Well, here, I'll do it over here since we're playing.
Ryan, on mine, there's on the top right, it says more with the 3 dots, and it's the first option under that.
Okay. Yeah, see, I don't know if you can see this or not, but I've got a chat, an invite, to record, that type of stuff. So since I'm presenting, I don't think I have that option here.
Okay, I'm trying to put mine back on the side where it was, and I can't seem to get there.
Mine just went behind my PowerPoint presentation, which is annoying.
There it is.
Well, I'm actually showing it in. This is my window here that I'm moving, and so I've got this is my interface on my end to see you guys.
Okay.
And back off.
I don't have a raised hand thing on mine.
So at the top of the video screen that's giving the presentation, is there a more button up there? So for me, if I come up to the very top of my window and kind of mouse up over the top, there's stuff on the presentation.
If you go to the bottom and there's the participant, you can click on that and it brings up another window, and there's raise hand.
Okay. Got it. I see that now.
All right. So we're after 3 o'clock here. So does anybody have any questions that they'd like me to attempt to address or to discuss some?
I'd like to learn about vision and PID a lot, because I don't know much about that.
So I've got the plan today was I was actually going to go over this entire presentation. It was going to be, for those of you new to it, it was going to be absolutely intimidating, drinking out of kind of like a fire hose type thing. But there's actually some really good resources. I'll bring some of those up here real quick since we've got time and can think and talk about this for a few minutes. So if you come out to National Instruments website, and I'll actually back out and bring a new tab so we can do this from the beginning. So ni.com/FRC. I have it on good authority, directly from NI, in other words, that they're trying to fix this page so the drop page is more along the lines of what we've had in the past. Their website update for their community groups, when it kind of blew things up a little bit. But for right now, if you come over here and look at this first robotics competition documents, it brings up this document that's out here. And there's, if I'm not mistaken, at least 2 that are specifically related to vision, and one that covers in detail the PID loop section. This is that command and control tutorial I mentioned during the when I was talking about the robots. That's a really good one to kind of read over if you're interested in that command and control programming paradigm, basically. It's just a little bit different than the default project. But if you do you can do a search here in this group for vision. It should sort us out. So this is a 2002 one. It's a little older, but if you're wanting to use the vision, the Labview vision stuff, most of it will still be applicable. We have an image processing tutorial from 2015, and this is the one that I actually had my students last year reference a couple of times. It's got some really good information in that one. And then, ooh, there's something from 2016. I don't think I remember seeing that one. That's new, or at least that's new to me. Obviously, it's been up there for a little while. So those are a couple of resources for you on that one. For the PID, I think we can do the same thing. And I'll actually show you here in Labview in just a second. Yeah, this is the one I was thinking about for the PID tutorial, this 2015 one. It talks about a whole bunch of stuff for the PID loops. Really good information on that. However, I also have another resource for you. So, remember I had mentioned about the example finder earlier? There's actually some built-in, well, I say built-in, you can't get to them yet until you install the 2017 FRC update. But if we go to find examples, or once you've got it installed tomorrow, you can come to find examples and down here to vision. And I was actually looking at these last night, and these are actually pretty slick. See if this 2016 one is what I think it is. Ooh, I need to close out my project here. Just a minute. Okay, so the vision example is already opened. This README should be some, of course, pops up on the other screen here, just a second. So there's a little README about the vision example itself that you can look at. And then we've got the color processing example. And that brings up a screen that looks like this one. Now, on these examples, before you start them, check the instructions to make sure there's nothing special that you need to do. Sometimes you need to have, like in this case, you can do, it's set up for either files from a directory, or that you can use a USB or IP camera connected to your laptop. So sometimes you need special hardware for some of the examples to run properly. Oftentimes, like in this case, it should run just by clicking the run arrow. Now, what we're looking at here, obviously, is the, looks like this is what, 2-3 years ago, the target that they gave us for the high goal. And so with this, you can see, you can change it, and you can see a bunch of information about what, of them processing the target, on how to do that. And then some examples of it not filling the frame. You can kind of flip through this and see what they did. But what's cool about this, it's still running. I'm just going to do Control-E to bring up the block diagram. They give us the code of how they accomplished what they're doing in the example. And so you can use this as a basis for developing your own vision code. Now, what I will kind of explain on this just briefly here is, I need to stop the code just a second here. Okay, now this is one of the few programs that Labview or National Instruments has put out. They did not include a stop button, which in this application actually surprises me slightly. So I'll use a stop button. So on this side right here, this is the camera portion setup effectively. And so if you're using a camera, you'll be using that. If you're using the files, it would do this toggle. So in your robot code, which I just closed, I'll open up here in a minute. I'll show this where this portion of it would be in that as well. But then you've got, so it's marked here as acquire image. And then from here to here is effectively your processing of the data. Now, once you have the data processed, you're evaluating the data based on some constraints, and then your results are done through here, down here at the bottom. And then the rest of this up here is closing back out. Oh, I guess they're converting the coordinates from and calculating the distance. That's what this last section right in here is. Actually, probably right there, I think. That's the annotation. So this is updating the online screen for this portion, the box, and your annotations over here. This guy should be calculating the distance in here. And this is ranking or scoring the results that are found in the image itself. So you can use this kind of as an outline of how to do something similar in your program. Does that kind of answer your vision question a little bit?
Yeah, that helps get me started on programming that. Thank you.
Yeah, one of the things I will tell you, and when you're looking at the web page, where did I put it? Not that one. Yeah, so when you're looking at, I think it was this one back here. Oh, that's taking a minute to bring up the presentation. One of the things that they show you, PID, here's the vision. Okay. So one of the tools that you might use while you're doing, especially if you're going to use the Labview, is the NI Vision Assistant. And this is and this will be in a slide presentation when I post it for you. One of the things it does is you can actually generate the Labview code. And so there's actually an example in here of building the algorithm for this year. This is the year they did the basketballs. And so you start from acquiring, like this is a saved image, but you get an image in, and then you build up the routine in the Vision Assistant. And it talks about, it's not in great detail on this one. There's a white paper on this exact example on NI's website, and I think that's one of those two vision guides that I showed you earlier. It explains the different steps and why they did what they did in this one. You can generate this Labview code, and we'll go through a bunch of these little screens to select what you want and how you want it, and then how many of the indicators and controls you want to see. But this is an example of the code it generates. So it's not real pretty, and it takes a little bit of exampling, or kind of, not exampling, but experimenting to come up with a really good, efficient vision routine. And that is part of the challenge of vision at this level, especially if you don't have a lot of experience with Labview. Figuring out how to make this efficient or how to improve upon the existing efficiency is sometimes a little ornery. And so if you get stuck, I encourage you to reach out to either put a post on the NI forum or reach out to myself. Or I know at Gordon Cooper we do a bunch of build days. Come to one of the build days and ask the questions, and I'll help you through it, because it can kind of get frustrating sometimes on some of this. So just be aware, is all I'm saying on that. Oh, and the other thing, this is not necessarily optimized. This is I use this as a good first step, and then I'll come in here and decide, do I really, really need that, and can I get rid of it? Or I'll time each of these functions to see which one takes the most time. And if this is the one that takes the most time in there, then I'll see, well, is there a different way I can do it that takes less time? Because, of course, time from image acquisition to decision is always, the faster you can make it work, or the faster that it can have a decision, the better. Just a general comment on sensors, and especially if you're integrating with vision, a really good thing to keep in mind is that you will have latency. You can very, 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 very rarely take, especially an image, but even with sensors, it can happen some as well. By the time you have the data in hand and can make a decision on the data, time has passed. And it could be a couple of milliseconds to a couple of real seconds, or hopefully not a couple of minutes. But if you take a snapshot of when I took the image, or at least a time base of when I took the sample from my sensor, and then whatever you're going to do processing-wise, when I've made the decision of what I need to do, if you can compare my current sensor results, not necessarily image, to what it was when I took the image, you can then have an idea of if I'm in motion and I say I'm moving forward at, I'm just going to use numbers here, 1 inch per second, for an example. And I took a picture, and at the moment of that picture, of course, I took an index of my encoders and whatever other sensors I had available. And by the time I'm done processing image, I'd calculated that I needed to shoot my ball or fire my Frisbee at 50% speed because I needed to go 3 feet. Well, if I'm still moving at 1 inch per second, that is not, if I'm considering feet, it hasn't changed a lot, but that value's changed. Maybe I was in the middle of a turn when I took my calculation, and I calculated it needed to be up 3 degrees and rotate my gimbal 5 degrees to the left or something like that. Well, if I'm in the middle of a turn, obviously that data is now skewed slightly based on the time it took to calculate the results from the image. So if I know where I was when I took the image and where I'm at now, I can start to do some math for if I was in a turn, what's the correction? So maybe I was turning towards my target, and so that correction went from 5 degrees to the left down to 2 degrees to the left is the actual at this moment. You can sometimes correct your data back based on what it was to what it is now. So hopefully I haven't completely blown up your brains, but just some good information and some things that I've found that can cause challenges sometimes. There's also a really, really, really good presentation about camera selection, algorithm development, and such like that was done at Nationals last year. And if you look on FIRST's website, under the presentations for last year, there's links to, I think somebody posted a video, and if not, at least just the slides, that has some pretty good information about some methods that they did. And I think he was using Java when he programmed his. So it's text-based, but you can use the same concepts in Labview. So that's probably more information, or I probably talked longer than you really needed at the moment, but anything else? This presentation does also have some PID, closed loop versus open loop. Let's see here. Yeah. That you can kind of look through and you can kind of look at as well. Again, if we do some live presentations, my goal is to go through this in a little more detail than obviously right now, but there is some pretty good information here as well. And the old versions of this portion of the presentation is actually copied from the 2015 presentation, which is actually already posted on NI's website. So under the documents, I think there's the quick start guide down here. Yeah, this one right here, very top. So a very large portion of my presentation actually came from this presentation and I used this in 2015 year, this exact presentation for when I did the workshop in 2015. And they've got some vision examples, a vision example in there, and then the PID control stuff in there as well. And so that's available right now that you can download that. And so, not all of these resources are still available. They are all still there at NI's website, but some of them have gotten very difficult to find with their new update on their website right now. They're trying to fix that. Anything else?
I typed some questions in the chat.
Yeah, I just was pulling that up. I realized I didn't have it active, so I went to go look at it. Okay. So you're interested in calling the commands or inputs associated with the RoboRio. Can you expand upon that a little bit for me?
I mean, I've used other Labview modules, you know, the like digital analog input output, and some. And so I know that these, like, each module has, like, you know, work with channels or something like that, and just wanted to know how that worked with the RoboRio, because I've yet to work with RoboRio, and just wanted to see, like, what, you know, how, I mean, I know that there's, like, some things we plug in and that kind of thing. I just wanted to see, what is it, just like working with channels and then operating on some different inputs?
I can show you here a little bit.
And we might
show you
do more of that tomorrow as well. So
yeah, and I can show when we do. Are you going to be participating in the quick build session tomorrow?
I'm gonna try.
Okay. Well, obviously weather dependent, because I know I'm here with about, it looks about 2 inches of snow outside right now still. So we'll see how the roads are in the morning, but I'm planning on being there myself as well. Okay, so
I think it was Harold, and he said that he indicated it was happening no matter what tomorrow, and then just a matter of how to get there.
Being able to make it, I understand. So we'll see. I'm right now at this point planning on being there, and we'll just go from there. I'm supposed to be one of the ones doing the quick build, so I kind of need to be there if I can get there. So we'll go from there. Okay, so on your question, this is the demo project that I did in the last session, demo 1, and this is an example of what you're when you create a new robot project, what you'll get. When you first start it, it'll usually, like this one I chose, it had an arm with it, and then when I open up the begin of the eye, and this is the block diagram for it, or the front panel, and here is the block diagram. What we've got here is, this is the arcade drive, so it's using a single motor instance and 2, obviously, motor controllers, one for the left side and one for the right side. In this case, it's a PWM controller. And then we assign it the name of left and right motors for the drive. For the joystick, I'm going to say that it's on the USB port 0, and that's linked to what's shown by the driver station. And I still actually have that up at the moment, so I can show that to you. So down here, my attack 3 is plugged in at 0. I actually have another controller that I'll plug in here for just a second so you can see what it looks like with 2 controllers plugged in. There it went. Okay, so I have a gamepad, the F3110, which is with a Logitech, one of the ones you can get, maybe coming in as it came a couple of years ago as one of the options for your control stuff. So I have now one on 0 and one on 1. And if I wanted to switch this, I could come in here and switch it down to USB 1. But this is going to be very similar to what you're going to do for most of your channels. If the device needs a PWM channel, it's going to give you the option. And notice that these are PWM 0 through 9. And then these are listed as MXP 0 through 9. The MXP is the expansion port on the top of the RoboRio. And then these are the ones that are built onto the RoboRio. So if I come out here and I'm going, I don't really remember, let's look at one of these real quick. Medics, actuators, I think it's under actuators. Servo, that's the one I'm looking for right now. So if you're wondering about a servo, we can bring up this servo example here real quick. And what it shows me is this is just a graphical representation of the RoboRio. And over here is it has it listed as PWM channels. I know this is tiny text and I apologize. That's why I'm trying to move the mouse as we do it. But giving me an idea of, we use a PWM cable to connect to the servo, and that you can then use one of these channels, and this is the 0 through 9, and this would be the MXP connector. You actually have to break these pins out into some type of a breakout board to get to the individual pins. Because there's a mapping of this, but it'll be one pin, and you have to bring in your power and your ground from a secondary source on there. But this again is a selector for what channel you're wanting to experiment with. And then when you run this example, you can actually set the angle desired, and it'll move the servo, not on the picture, but in real life, to the angle that you're wanting to go to, like you'd expect with servo control. If you've got questions about like general sensors, let's look at the sensors palette real quick. Look at one of these. Motor with encoder. I saw an encoder question a second ago, so I'm going to just bring this one up as an example, just so we can look at it real quick. And I'm going to use this in two ways. So this is a motor encoder example. So on this side, our motor controller, the controller for the motor, in this case is a Talon SR, or showing a Talon SR just for in the picture. You connect the motor controller to the PWM channel, but the encoder on the motor would be on the digital I/O channel. Now, they've got some recommendations for what channels you use for encoders. A lot of these can be set in the software itself. So like in this case, we're using for the motor controller, like just for this one right now, it'd be PWM 0. The encoder for the A channel is on digital I/O 0, and the B channel is on digital I/O 1. And so you'd end up using, I don't know if you can see this, but the white wire is pinned to 0 and to number 1 over here. When you open these examples on your own computer, you'll be able to see this a little bit better. You can also, I think, click on some of these graphics, and it'll help highlight some stuff for you a little bit better as well. Then they're doing some correction factors for the encoder. They're saying the wheel diameter is 6 inches. The distance per count, or per degree of the encoder, is this distance. Your maximum rate of speed for the motor, or for the your encoder, is going to be that. The number of samples that you average to try to help stabilize the value, and your decoder type is a 4x decoder. Now, some of these details we can find out more about in the code itself. So I just opened up the block diagram, and now we've got all those indicators. Down here, we're saying open the PWM reference here, and we're setting the speed of the motor here, and we're closing out the motor over here. So for those of you that have actually used this ecosystem before, this is the portion that would go in your begin VI. This is the portion that would go in your finish VI, and this would probably go in your autonomous or your teleop VI portion. And I'll show you those here in just a second. For the encoder portion of it, here's our details. Your 2 digital I/O channels, and they're actually using a pipe function in here to go to the analog input source. They're opening a channel on the digital I/O, and then they're converting it over to an encoder open based on those open channels. And then they're setting up the timer functions. Some of this is a distance per count. Not all of that's required. So if I open up the help, Control H to open the help, the context help for this VI to open, the only thing that's required is the A source and B source. So you don't have to use the decoding type. Well, you probably want to use a decoding type. It'll default to one of them. But your distance per count, and you can set that in, or you can actually deal with these encoders in pulses instead of by distance. And sometimes that's helpful for when you've got an encoder on a gearbox that's located on the motor, and you've got a transmission between the motor and your wheel. And so now we've got some but some multi-gear speeded high and low options for some of those transmissions. And so now you've got 2 different speeds you have to deal with, or pulses per inch type levels that you have to deal with as well. So as the complexity of the device gets more complex, the complexity of some of these programs will get more complex as well. So back, if I'm going to use this example to build up my robot, I'm going to come back. This is the begin.vi from my project, and this is my project. I know this is getting confusing. I'm sorry. There's a lot of stuff open. So let me close the begin just so we can open from here. The begin.vi right here. Double click it. It should already be open here. And here's the block diagram, and here's the example. So if I was going to use the motor for maybe it's going to be a shooter motor that it's going to spin up and I need it to be at a certain speed. I've already got my drive motor installed, so I would actually, you can copy, if this is exactly what you want, either copy this out of here or you right click, come to the WPI robotics library, the robot drive, open, and it's going to be 2 motor, 4 motor, and there's actually a single motor in here somewhere as well. Open motor. And now you'd select what controller you're using. In the example, they were using a Talon SR, so we can use the same one if we wanted. And in this case, they were using the control. I'm going to probably, in my begin.vi, I would use a constant. So I would right click on that PWM channel and create constants. And I basically reproduce what I've got here at the beginning. Now I'd also use what we've got up here. So they're using, we're naming this and saving it to a location so we can reference that by name. So I come back to my WPI library, motors palette, motor, and there is a set, WPI control reference num registry set. And again, you're setting the value in, follow the arrow. We do the same thing to set this one up, and I missed the wire. And I would name this something that means something to my robot. So this takes care of our begin portion. Now, this is something else that you might want to do too, is if this is something that's going to be spinning, you probably want to set the safety, just like they did on the drive motors up here. And so you'd use, it's in the motor palette again, for the safety feature, the safety config. Especially if it's got potential to hurt someone, it's just better to use the safety than not. And if you're showing off your code to judges, I'd like to see the safety stuff set up. So just an FYI on that side of it. So our begin is almost complete. Constants to enable it. Now, if I create a new device and begin, I always go to finish to close it out. So here's my finish. Here's that. Now my preference or my habit when I'm doing this in here is to actually just drag and drop that name over to here, because then I know it's exactly the same because it is referenced by the name itself. Now I need to close out, so I need to read or get the reference value, which in this case is the driver. And wire it in, and then back in my motor palette is a close. All right, and if you're asking any of my kids from our team, close ref, say data, etc. Okay, oh, I've got the wrong drive here. There we go, I had a drive instead of a motor. If you ask any of my kids, they should tell you that if I set something new up, I open it and I go and close it immediately, and now we're ready to program with it. And you could do this use this now in your teleop or your autonomous, and then you basically copy this then into your autonomous or your teleop. For the encoder portion, it'd be the same thing. We would do this in the begin, this in the close, and this chunk in here would be in our teleop or our autonomous portion based on what we're trying to accomplish. Does that kind of answer your question a little bit? And I'll touch a little more on the encoders here in just a second, Brandon.
Yeah, I think for my question, that was plenty. I mean, I think it'll make once I see what kind of what's in these other toolboxes or whatever you want to call it to go with the FRC, it'll make more sense.
Yeah, yeah, and there's The WPI, there's a pretty good documentation of the WPI library in itself. Let me close some of these just so it's not so busy for you. There's a lot of windows open. I know it gets complicated and busy very, very quickly. Okay, so I closed too many windows. Okay, so in this particular, like for the WPI library in itself, you've got the drive and motor controls. You've got joystick to be able to read the values from your joystick, and that's being passed to you to some degree. It's coming from the front panel or from the driver station. Then you've got different types of sensors. You've got gyros, encoders, potentiometers, switches. There's some third-party sensors out there. There's an ultrasonic. There's counters and accelerometers. You've got different types of actuators, whether it be motor control, which I think is the exact same as the panel how I was just using from the drive. You've got servos. You've got relays, solenoids, compressor, which is already built in already to, or should be, or maybe built into your program already. And there's some third-party actuators that are available as well. Links to your driver station, the dashboard, your camera. You've got communication protocol stuff that you can do, serial port, I2C, SPI, CAN, and then the utility stuff. Probably won't get into a lot of that. That's getting into some pretty advanced stuff. And then some power stuff. So if you wanted to check power values on some of the different devices that are in the controller itself, as well as the power control module and stuff like that. And as you get into this, if you come up with an idea that you kind of want to use a sensor for, check the WPI library, check a couple of the other sources. Another one I think I may have mentioned is Chief Delphi's website. Is a really good one. If you just do a search for FRC or FRC and Chief Delphi, you'll get the link on that one. I do not expect to be a water game this year. Just putting that out there. It's one of the forum posts on Chief Delphi that's always live. Is it going to be a water game this year? But anyway, they've got a lot of really good tutorials and how-tos on some of these different sensors and some of the different sensor types. And if they throw a new sensor into the package sometime, into the kit, there'll be people talking about how to use it, what is it good for, that type of stuff out on those different places and those different locations. So yeah, and that's one of the things that we're hoping to do some more this year. Obviously not in necessarily the heat of the build competition, but we're going to try to do over maybe some during the build season, but then afterwards, some videos about different sensor types. How do you make it work with the Robo Rio? We've got one of the kids on our team this year that's has done pretty well so far with C++, and so he might, at the end of the season, actually try to convert our Labview code over to C++, and kind of an example portions of that as well of how he did that and why and what some of the decisions he made. We're going to try to release and document a lot of our robot code as well at the end of the season of what we did and why for some of those decisions as well, just for people this next season. So I hope that helps. Brandon, for your questions on how do you program the encoder, are you just asking generically, or is that kind of example of what I was showing that just with the motor and the encoder? Is that kind of what you wanted to see?
Could you go a little more in depth with teleop and how to program it?
Sure. So with this example, we've got this portion in here is a good base example of some of the things you need to think about with an encoder. Now you don't have, like I said, we don't have to necessarily use the number of samples to average, and we don't need to necessarily be using this distance per count portion. If you're using a full 4x encoder, you've got a lot of stuff happening, and they've got some new stuff, in this year's release. Let's see if I can find it real quick. Spinning my wheels just a little bit here, but let's see, sensors, encoder. Okay, so they're defaulting to the 4x version this year on the encoder open. So you've got a lot of data that's happening and being passed into the FPGA, and the FPGA on the RoboRio is what's actually giving you or calculating those pulses and to giving you out to a effectively a distance or a degree per pulse. And if you noticed in this example here, it brings the front panel, they're showing a 0.288 distance per degree. That's a really small number. And some of these encoders are capable of giving you even smaller numbers. So one of the things you have to watch is if it's a really, really highly precise encoder, you don't want to spin that thing like at 100 or 1,000 RPM, because you're basically going to end up with a flat line and you won't be able to read it properly. So if it's going to be something that's spinning really fast, you actually want less pulses per revolution to be able to read, because once you get into high RPM, you're effectively looking for an RPM reading. And a single pulse per revolution is more than enough to be able to calculate that, unless it's going to be at slow speeds. And then more pulses help with that, that calculation. Now, if you're using it for drive control, which is, I'm assuming, where you're kind of going with your questions on that, a couple of things you need to think about is if you're stopping and starting quickly, chances are your wheels are going to slip a little bit either on the acceleration or on the deceleration. And so your position on the playing field in relation to where your encoders think they are may skew a little bit based on that. The other factor that can affect the encoders versus position on the playing field is if you're using the Mecham or the Omni wheels. You need to rotate them slow acceleration, slow deceleration, because of the Omni or the Mecham design, your robot will coast on those free wheels a little bit. And so your position can end up being difficult to determine. If I'm starting at my start position and I want to go forward 3 inches and turn left to 45 degrees and go forward 6 inches, if that's the type of control that you're trying to do, you've got to be very smooth in your acceleration, deceleration, otherwise you lose your position in reference to the encoders at least. Now, with all that said, oh, I've got a window open here just a second. Okay, I know there's a conflict. Okay, so now what? Close. I don't want to deploy this. Okay, so one of the things you need to be able to handle is you need to be able to reset the encoder value. And what's actually happening behind the scenes on this is you're resetting not necessarily the physical encoder, but the memory of am I at 0? In which direction? So if I'm driving forward, I'm going to go forward 10 pulses. If I happen to stop for whatever reason, or if I happen to know that I'm at a wall, and maybe that's part of your driving for the autonomous section, I don't care what position I'm in, because I'm going to go slam against the driver's station wall against my opponents, first of all, to try to freak them out. But second of all, that re-indexes my position. So maybe I had to go for an obstacle in that forward drive motion, and I know it's rough. I know my wheels are going to slip. So when I'm just going to drive all the way until I hit that wall. And I'm going to drive forward for about for maybe 2 seconds to get up to that wall, hit it real hard, and stop. And I'm going to zero my encoders, because now I know I have a 0 index because I'm physically against a hard stop. Now I can back up slowly, turn to the right, and fire my playing field ball or boulder or whatever it may be at the goal. And because I indexed against the wall, I had a very highly accurate position of where I would locate it. Now, I may not know how far away from the goal I am, but at least I know I'm 3 inches, 2 feet off that wall. So you need to think about, when do I reset my encoders, on how, or when and how, if you're in the autonomous. If you're in teleop, you need to decide how you're going to use the encoders to your advantage. If you're simply using them for like an RPM gauge, then you may not really need to reset it. You may not need to worry about that at all. But if you're going to use them for positioning or distance, make sure you have them indexed in such a way that makes sense to you or the playing field or whatever your objective is that you're trying to accomplish. From there, when you get the encoder value, if you set up this stuff at the beginning for the decode type, which you need to set, but your distance per count and your minimum rate and your number of samples to average, you should have either a pulse or a distance coming out of here. And that all depends on how you set this up initially. And then you can play with your math to make this work for what you're doing. If you see here, they're using the wheel diameter in inches to convert this pulsed value that's coming out. So one of the things they're doing is they're getting the current angle of the wheel, they're getting the number of revolutions, and then they're using that to calculate the physical distance on the playing field. And then this is actually the distance value, not this. The value that's coming out the bottom down here is the rate, so the degrees per second that you're moving. So if you're driving forward, how fast are you driving forward is effectively what that's helping to tell you. Does that answer your question, Brandon?
Yeah. Say, what if I wanted to start autonomous right at say one position? I would reset it, and then you'd say go for a certain amount, and then you would use the get to get that amount.
So what I would do, in your begin VI, of course, you've got to set up the encoder stuff. At the finish VI, close it out. Please, please, please do both of those things. Otherwise, it makes life interesting and difficult. But when I get to the teleop side of things here, and I may need to step back and show you this from the main also, so that you see how this is referenced. Well, that's the wrong project. It's over here. Okay, so let's think about this from the, let's, you may already know this, but I'm gonna talk about it just briefly anyway. So this teleop VI runs every instance, or it runs and runs and runs and runs and runs over and over, one instance at a time, basically. Every time this loop, the scheduling loop, loops around. So here's teleop right here. So when this loop runs, it's going to run teleop once. It gets to the end of the loop. We're not stopping the program. It's going to run it again and run teleop again and again and again. So that's the instances of the program in teleop. So you're going to be getting pulse this information from get. So this get, and I'm just going to copy it over here so you can kind of see along the lines. You're going to have your, oh, they don't put it over there. You'll end up with a, let's just do it so you see an idea of what it looks like here. Okay, so you're going to have, not that one on, that's the encoder. Sorry, wrong sensor. So you're going to have something along these lines in here, and we'll just leave it default now. You're going to then have some code of some sort coming out the backside. So this information is going to be repeating. I'm going to get a value, I'm going to get a value, I'm going to get a value over and over. So what you've got to decide on your side of the program is, what do I do with that number? If you are going to have, if it's going to be in your autonomous, it's going to be different than in your teleop. Because you've got to decide. So one of the things I've seen used in your teleop is I push a button and effectively the robot's controlling itself. Maybe it's going to self-aim to fire the boulder at the tower, or maybe it's going to self-align to pick up the next object from the human player on the side of the field, or something along those lines. Then what you do is you'd run this get into an equation, kind of like this is, but helping you make a decision. Do I need to move left? Do I need to move right? And that would then, the output of that decision would be then wired into your motor controllers. How much do I move left? How much do I move right? If this is going to be in your autonomous, then we might use it for, like you said, I want to move forward 3 inches or 1 foot. And so what it would do is I'm going to say, give it how much I need to move forward, And then are we there yet? Are we there yet? Okay, we are now equal to or greater than 3 feet. Now what do I do? Does that kind of explain it for you there, Brandon?
Yeah.
Okay. And there's some decent examples out there on Sheaf Delphi, and I think there's a good one on reference in the WPI library. And I think there's a white paper on the NI's website as well about using encoders and driving in the autonomous mode. So you can kind of look into that. The other option is if you guys are interested and willing to come out to one of the build days or the practice sessions out at Gordon Cooper, you're more than welcome to come out and we can talk about it in reference to your robot and your code directly as well. So just know that that's available as well. All right, the next question I've got in the chat session is, can Mac computers be used with Labview or do we need to use Windows OS? Okay, so the short answer is yes, it's possible, but the way they're going to have you do it is install Windows in blinds and use Windows. The longer answer is yes, you can use Labview with Mac, but it's not recommended to do it that way for the FRC session or the FRC season. And the reason for that is because Labview they don't have the most current release of all of the tool packs or the modules and such that we use that are all completely up to date on the Mac side of things, Mac native anyway. So that's kind of a little bit of a longer roundabout answer. However, we did have one of our students this last season that his personal computer was a Mac. He used the blinds in Mac and installed Windows 8.1, I think, and that was our drive station for last season for a large portion of it. And it was mostly because he was willing to troubleshoot and figure out how to make it all work on his computer so he could use his computer for most of it. We did, for the actual competition, use a school Windows-based computer that we got in mid-season for our drive station. But for all the testing, the code development, and everything else, we used his laptop just because he was the main programmer at the time. Anything else?
Hey, could you show a little bit how the potentiometer works as well?
For the potentiometer? All right. If memory serves, there's actually an example on the potentiometer in the example library or the example finder. Let's see if I can find that real quick. I don't recall where I remember seeing it. Okay, so the potentiometer on the teleop and autonomous side, you're basically going to get the value. And what you end up with, let me bring up the begin as well. Come on. I'm trying to move too fast. Slow down just a little bit. You end up with a open, a set, and we put the close in the finish of the eye. Remember to close everything out. Create constants. Okay. All right. So the potentiometer is what you end up with is it's effectively a voltage reading. A potentiometer is a variable resistor in its guts, effectively. You can use them for various things. One of them is helping you tell the angle. Say you have a shaft, maybe on the end of an arm, that's going to go from the ground level to maybe 90 degrees vertical or something like that. One option is you could effectively put a potentiometer on that elbow joint, and then you could calibrate it. When I'm at 0 or down touching the ground, I'm going to get this many volts out of the potentiometer. When I'm pulling vertical or at 90 degrees up, then I'm going to get this another voltage reading, and it's going to probably be linear between the 2 points. And then you can take that voltage reading and effectively calculate the angle of your arm if you wanted that. Another option you can use a potentiometer for, and I've seen a couple of teams use this very successfully, is to fine-tune your autonomous. And so what they use it for is they use the potentiometer as an offset value for an equation. So maybe in my autonomous, I want to go 4 feet, 4.753 feet, just for a random number to throw out there. Well, you get out there and it works perfect at that number for my home field and my practice sessions. We get to competition and, oh, the carpet's a little thicker than what it was at home, or our carpet was worn out and theirs is brand new, or theirs is worn out and ours is brand new, some variable. And so now instead of that perfect 4.753 value that we had, now it needs to be 4.756 or some other really small, minute value that you want to change. Or maybe it's a really big change, I don't know. And so they have a potentiometer physically on the robot. They reach down and twist forward or backwards to tune that number up or down. And so what they do is they use the get value and relate it directly to a numerical correction value somewhere else in their code. Does that kind of make sense, Brandon?
Yeah.
Okay. Does that answer your question?
So you said they could like twist it and then it would auto-correct itself to the new number that they needed?
Yes. Yeah, and so what they did is they used, so in the get right here, they got this value out and they corrected it, or they used it as an offset value. So maybe the potentiometer value of 0 equated to, they did the same thing what you do with your joystick. If you need to get the range for the position and convert it out to a actual, like if you're like your joystick goes from 0 to 1, and if you need to go from 0 to 100, then you've got to multiply that 0 value by 100. If your joystick outputs a 0 to 1 value, you multiply it by 100 to get up to the 0 to 100% type equation. You do something similar. You'd have a correction factor or a correction equation to go from the get value of the potentiometer to the correction value that you want to correct. So maybe you want to correct from a 0 offset, and that is going to be a potentiometer value of maybe 0.35, because very rarely do they get to 0. And so you set up your equation that 0.35 is equal to 0 for your linear equation that you set up, and then maybe 1 volt or 5 volts or whatever the output on this side ends up being could be, yeah, so it's going to return normalization, return volts, 5 volt rail, and controllers used it, assumes. So the normalized value is from 0 to 1 for the output on this. And so you'd correct this up to or across to whatever you need to for your correction factor. If you're using it for like a distance calculation, or maybe it's an angle for an arm or a grip tension or something along those lines. Does that answer your question?
Yeah.
Okay, good. Anyone else have a question?
I just had a quick question. Like these VIs, what is it, like the beginning VI and final VI, that's all stuff you made, or is that something that is populated with software?
I will show you real quick. In the presentation, I think I created a project. Okay, so when you start, or if you need to restart in the middle of the season, which you'd be surprised how often that actually happens, you've got this option up here for a new FRC Robo-Rio project.
Okay.
You'd select this. I did click it. There it went. And you'll get this program or this window that pops up, and it's going to build this for you. You'll at least have a basic template to start from. And at the quick build tomorrow, we'll use this, and we'll actually not go much further than this on the actual coding side. What my session on the coding stuff is going to be focused on is getting the RoboRio imaged and ready, getting the radio imaged and ready, getting those things tested, and installing Labview on the laptops. So if you're coming tomorrow and you want to go ahead and download it and install Labview, that would be a leg up for tomorrow. just putting that out there. Anyway, go ahead.
Well, yeah, the main sponsor or head sponsor for our school, he's the one that's bringing the computer. So,
okay, that's okay. No.
That's why I asked about.
I have it downloaded.
My computer was a Mac, so I didn't know. I just wanted to see like if I could put the Labview on here, but probably not. Then.
Yeah, yes, you can. Like I said, we have one of the students that he does it. He did it the last 2 years, and he was our main programmer last year. And he I think it's called Blinds for Windows on the Mac. Is that right? And he basically he creates a little virtual machine on his system and installs Windows into it. And that's how he programmed the robot pretty much the entire season last year. So yes, you can, and yes, it is definitely doable. You can't do it native Mac OS, just native from the install files.
Is there a limit on how many computers we can install the Labview on for the FRC?
No, if you read the license that'll come with your kit, it's the guidelines are you are allowed unlimited installations as long as it's used for the FRC specific activities. So if you're doing FRC training, if you're doing it somehow in reference to FRC, you're allowed to use it. And the license will be good starting tomorrow, and it's good through like the end of February next year or something like that. I forget exactly what day it expires.
Okay. Not bad.
Yeah. So, and then each year, of course, you get it again next year. So you'll get a new serial number next year, and you can reinstall it again, basically. So does that answer your questions?
Yep.
Okay. I know just as we were signing off and actually got cut off right at the very end, we had a couple of questions for, I'm sorry, you guys are hearing my son in the background. They're peeking and saying hi to me. Anyway, so there was a question about, I'm a brand new beginner and I even had to look up what RoboRio was. And that's perfectly okay and perfectly fine. That's part of what these sessions are here to help with, is, I don't know where to start, even point. So what I would encourage you to do is, this is just ni.com/FRC webpage. Peruse this just a little bit, because this has got, and this is actually being updated pretty actively, and specifically this document section. The forum is nice because they're asking questions and such, but this section here, if it's got FR7, the 2017, they've got some pretty decent articles already going up right now about all the FRC stuff. But the other one to look at, I actually think I have it over here in this window, is this page right here. There is this getting started guide with the 2017, and they go through literally step by step almost everything to do with the FRC and how to get you going, whether your programming language is going to be LabVIEW or C++ and Java or what it's going to be. They've got some really good stuff. If you're wondering about the control system and the hardware, there's this control system hardware overview. There's the control system, so the wiring it. There's the software side of it. This is what the RoboRio looks like, top view, and it's maybe an inch or so deep at the deepest point. It's pretty small platform. This is our power distribution module, the pneumatics controller, and you can read about each of these devices and what they are. And most of these even have additional information like links to users manuals. There's the Roggow user manual. But you can actually just flip through and skim through this, and this will give you a pretty decent overview of the hardware that you'll be using, or probably be using, because there's a lot of different motor controllers that could be used. There's some of the cameras. There's the radio that we'll be using again this year, the circuit breaker. On the radio, by the way, there's a new one again for this year. The FCC banned the one we were using last year because it was too powerful and too configurable. And so they came up with a new version this year. The old ones are usable, but you have to configure it using our tool. So anyway, just a quick side note. There's the batteries, and you can flip through this, and it gives a nice overview of the control system in general. And of course, this is directly from FRC, so it's there. Everything they talk about in here should be approved, should be game ready, and, or not necessarily game ready, but game approved recommendations. And this is part of the build sessions you guys will be doing tomorrow in here. So, any other questions? If we still have questions, I'm willing to continue to talk and answer things. We're at 4 o'clock now, and I think I told Ray that I was planning on an hour if we had questions, and if there's more, I'm more than willing to continue answering them.
This is just something I thought about, that it's not really programming related, but and I don't know if you will know or not, but how much, I mean, is basically what we get in the kit all we're allowed to use, or we can tack on whatever we want?
Yes and no. Yes. Well, actually, no. Is really the better answer for that entire question. What you do in the kit is, well, let me explain it real quick, and then you can continue to ask more if you need to. What you get in the kit is a starting point,
okay.
And you can use a lot of things, but you can't use just whatever you want to use. There is an approved list. You do have to keep track of what you, like if you use everything out of the kit and that's all that you use, your accounting for what you use and how much it costs is really, really simple. But they do want, for part of, or at least if you're going to fill out the, if you're going to try to compete on more than just the robot by itself and its performance, there's a notebook that you can do, and there's a presentation on a notebook, there's the judges' questions, and there's a whole bunch of more than just the actual competition of your robot at competition day that you can be graded on. And if you're going to compete in those other avenues, you've got to keep track of what went into my robot, how much did it cost, where did it come from, and build a parts list for it, how much outside help did I have? I mean, there's a whole ton of stuff, and depending on what level of detail and how far you want to take the competition, you can do a ton of stuff. And like Gordon Cooper, what we've done, we actually have more than just the build team. We've got a media team. We have a report team. And like the report guys, what their specific task is to build the notebook. And yes, and they have to rely on the builders to give them the parts lists in many cases. But one of the things they do is at the end of each meeting, they go grab everybody's notes during the meeting and make a photocopy of them and stick them in the notebook. Because that's part of the build process of the notes that were taken and the ideas that were talked about and that type of stuff. But there's a ton of approved parts and lists of parts that you can use outside the build kit. And in fact, if you go beyond the basic chassis, you will need to get more materials, whether it be aluminum and water jet or CNC machine or laser cut or wood. In fact, there's a really, one of the teams last year and the year before built their entire 95% of the robot out of balsa. And so that was just one of their challenges they took on, was to see how much of the robot they could build out of wood. And they did wooden gears, and they did arms. It was impressive. Beautiful robot, by the way. So you are not limited to just what's in the kit, but you do need to be careful, because you can't just go and buy any motor off of the shelf and use that motor and motor controller. You can only use the batteries that are on the approved batteries list, and there's only like 2 of them. So that's why I kind of said yes and no at first, and then no, because yes, you do need to use more than what's going to be in the kit of parts. And yes, you can use almost anything, but you do need to be careful and check if it's on the approved list. Specifically if it's related to sensors and motors and actuators, that type of stuff. The list is huge, and there's a ton of stuff on it that's allowable.
Will that be outlined tomorrow, or is that already on some FRC website?
You know, I think part of the game manual's already been released. Let's see if I can find it real quick. No, that's the actual teaser. Okay, so they've got some stuff that's unencrypted. So on here, this is the complete game season manual, which is encrypted, and we'll get the encryption or the password to that tomorrow. There is at least some details, maybe not a complete list here, of the kickoff kit itself. And you'll see here that some of these are optional items. Some of these are based on if you selected the rookie kit versus the veterans kit. Here's some of the virtual kit portions in here. This is the first choice information, and then traditional edition ordering and such like that. So you can actually look through these links in here. Oh, well, that's going to go in overview. I really don't want to see that right now. Oh, it's encrypted. I'm sorry. I thought it was, the kit portion was unencrypted. That is encrypted also. I think some of the manuals, that one's encrypted. You can look at some of the past year stuff, but a portion of the game manual for this season is unencrypted, because I saw on one of the emails they posted had they'd released a large portion of it and just kept back the game details, specifics of it. So go ahead and dig a little more on the First Robotics webpage, because I think they've got some of it out here. I'm not exactly certain where it's at. I thought it would be right there. I'm not sure what's opening, but something's downloading. Maybe this is the one that's unencrypted then. Oh, no.
Anyway. That's all right.
You can also download.
I have a feeling it could be one of these things that's, super long. So, I didn't know if this was, or, I didn't know if it was, 5 pages or 500. So. Not that I would read the 500.
Yeah. So the rules and such, they usually have 2 manuals. One is a generic game manual, and then one is the game-specific manual that includes all the game pieces and the rules for this season's game. But the generic one is more about the building, what's allowed, what wire types you have to use between motors and the controllers, and there are some pretty specific guidelines that you do need to be aware of and look at in the game in both of the 2 different manuals. And I'm almost positive one of them is open already, and one of them, the one I've just found, is obviously encrypted. But you can also check out, there should be the first robotics game manual that you can download at the app stores, both Apple and Android. And you might check that because that may have the links over that are, some of them are free. The apps are free, but I think some of the information may be available now there as well. And the other thing, the other side of it too, is you can check on here, this is the control system specifically. On this one, you jump back one, that might actually be game information, not game, but no, I'm not seeing it right now. I'm sorry. That's the best I can do for the moment.
All right, good enough.
Okay.
Thanks.
Did I just get rickrolled? Is that what I just got asked? I'm sorry, I'm not sure I understand.
I thought I saw a Rick Astley video pop up on YouTube. I might have been mistaken.
Let's see, was it this guy? No, I thought it was on here when I clicked it. It's kit checklist. That downloaded. I thought it was one of these I clicked on that is where the link popped up from. This one right here? Yeah, it looks like it. Yep, I sure did.
You got Rick rolled.
I sure did. So, all right. Any other questions? Anything else I can help with tonight, or today at least? That's it. Like I said, I'm planning on being there tomorrow. I will be available for questions. We can talk over your computer or my computer. I'll be giving portions of this beginner and especially the install Labview portion of it for tomorrow. I will actually probably be using mostly this website tomorrow for the getting started section. On the controls, the software component portion of it, as we get things started and get things up online for the quick build session. If you guys are interested in it, last year what we did is we actually opened the programming room a little early before the session started. And for those that had their laptops and were ready to start the install, we got that started before the presentation. And then that way, hopefully by the end of it, most of it was actually installed. Someone will be there to monitor that room, or we will have the door locked. So once you get it in, get it going, we may lock the door and walk out for the presentation portion of it. So just know that that's available. One random question that I was thinking about is anybody with us today, I know we don't have a lot left, that's not from Oklahoma?
That's where I grew up. Moved to Oklahoma in 2009 to go to OU, and then moved back in August of this year to teach at Aztec.
Oh, awesome. Awesome. Yeah, because I know that the gentleman that I've been working with at National Instruments said he was going to tweet out the sessions for today. And so I was just curious if anybody that's not an Oklahoma team or associated with an Oklahoma team right now might be online. We're just going to give a shout out to them. Yeah. So no. That's awesome. I'm glad to have you back in the Oklahoma area, and I hope the season goes well. If you're going to be at the build session, come say, or by all means, come say hi to me, and I'd like to shake your hand. So.
Let's see. All right, so you're Ryan.
Yes, I'm Ryan Roggow. I can turn my camera on for here a second, just a second. Not over there. So, hello world. Bring that over there. There. So I'm actually looking towards the camera versus away from it. So yeah, hopefully I'll see you tomorrow, and you guys have a wonderful day. I'll stay on a few more minutes here. If there's any more questions, by all means, let me know. Otherwise, I think we'll call it quits for today. Thank you guys for joining me, and hope you guys have a safe trip tomorrow for wherever you're going to go for the kickoff stuff. Stillwater, hope to see you there. If it's a Tulsa one, then good luck, and hopefully I'll see you at competition. Hey, Stuart, if you're still online, did I give you some resources that were going to help you a little bit? And did I answer some of your basic questions?
Yes, you did. Yeah, that was really good. I'll try to read through some of that even tonight.
Yeah.
So I'm
good. Good.
My expertise really is in mechanical. Be learning some electronic stuff too. I've been with Best for 12 years. I coach a Best team, and we have a team, but I haven't been highly involved in that. Mostly it's just been in safety and tools and things like that, which will be my area of expertise on the Metro Tech mechanical monsters. But I learn the programming aspect of it. As head coach, you don't have time to really learn anything. You're busy running everything. Yeah. And so as an assistant coach, I hope to be able to learn a little bit more about the programming and other things like that, so that I'll be more useful to the team. Should the people that don't know that, if they're not around, at least I can help some of the new beginners with some things, I hope. So anyway, this has been helpful. I'll go look at those documents. Hopefully somewhat this first week I'll get to look at some of that. So good. We have a really good program on our team, so that's good.
Yep, that's great. That's good to hear. I'm glad I was able to help a little bit, and by all means, if you guys get stuck or if you just have a question, and by all means ask it. I'm more than willing to help wherever I can, and as the Sprockets like to say, that they've got the guy that he's on their team, but boy, he helps the other teams just as much or more. In fact, they laughed this last at the regional here in Oklahoma last year. I was literally in our booth for all of 5 minutes the entire competition because our guys didn't need me, and so I was out helping other teams, and I'd stop in for a few minutes, and then I'd be gone again. They knew that if they needed me, all they had to do was raise their hand. But
yeah, I've been affiliated with the Ninja Monkeys now, so you would know Kermit Alexander.
I've met him a few times. Yes.
Yeah. Well, he started in Best, and so I kind of I call him my adopted son. I helped raise him up in robots. He was amazing from the first year we had him in Best. He was just amazing. He's he's at UT Dallas now. He got the McDermott scholarship.
Oh, that's awesome.
So yeah, and he's doing well. I keep in touch with him. He's so he's he's keeping his focus on his studies, and he went down there and immediately got involved in the church, you know, to make sure he didn't get involved in other things. And
yes.
so
easy to get sidetracked when you're with all that.
Yeah, he's great kid. It was fun watching him even when we first started in Best, 8th grader, freshman. They were having trouble with the game field, and so they all these engineering professors came over and asked to borrow Kermit, and he was gone for about 10 minutes and came back, had it fixed.
Awesome.
So
yeah, I got my start in mentoring or helping to mentor robotics teams with Best as well. I just completely lost. It's just not hit me right now. What his name was, the head coach out of Moore, Oklahoma. But yeah, I did, I think, 4 years with Best, and then moved out here to Shawnee and went to a air show, and Gordon Cooper they were showing their robots. And so I was talking with a couple of the kids and a couple of the coaches, and one of the kids asked if I knew anything about Labview, and I laughed and said, a little bit. And he said, oh, really? We need something that might help us with Labview. Would you be interested? And so that's how they hooked me, and I've been helping them for, this will be 5 years now. So
yeah, it is certainly rewarding to watch these kids grow, and just know, you know, that many of them, if they were not involved in robotics, they would be getting in trouble.
Yeah, that's right.
But they keep so busy with robots, they don't have time to get in trouble.
Yeah. Well, and some of them, they realize they never even considered that as a possible like they thought maybe career, they may be teaching or music or business, and they get into robots and go, oh my gosh, this is so awesome. So yeah, it's cool.
Yeah.
Derek Black, that's it. Yes. Blackford, Mr. Blackford. That's who is the head coach.
Oh, Andy.
Yes. Yes.
Yeah. Yes, I know Andy well. We've
yep.
As a matter of fact, when his Best team dissolved, we absorbed a lot of them into our team.
Well, that's good. That's good. I know that he wasn't going to do it anymore. Many years left. But I was just after I left, because his son was about to graduate.
Yeah. Well, I still have a son. I've had three boys and 2 daughters involved in this, and my oldest son just graduated from OC. Excuse me, in electrical engineering. Now works for Tinker.
Awesome.
My middle son, as a result, decided he did not want to do engineering. He wanted to be an entrepreneur. And so he worked with a ministry up in Chicago for about 5 years, and now he's in Florida working on $1 million houses. And my youngest son, Scott, he's a junior. We do 5 years of high school. We homeschool, but he's out at Francis Tuttle. And as a matter of fact, this weekend he's going to be doing a VEX competition that he actually hadn't started. One of the other students had asked him for help, and then he got involved in the team, and the other people kind of bowed out, and so I don't know how many kids are going to be going, but I know he'll be heading to where's he going, Ian? Mustang?
Is it the FTC?
Oh, it was canceled. They canceled the competition tomorrow because of the snow? That's what my oldest son walked in. So
it's the FTC competition, or is it a different one through VEX?
No, it's a different VEX. It's not FTC.
Okay. Okay. No, I'm just curious. Yeah.
Yeah. Well, that's weird that they would cancel it tomorrow. I mean, Oklahoma is horrible at cleaning their roads, for sure.
Well,
you
it's
get
not so much
more.
the cleaning; it's the melt and refreeze. It's a hard ice.
Yeah, that'll be one of the problems tonight. But anyway, we plan on driving with MetroTech. We plan on taking a van up there or a bus or something and being up there at kickoff tomorrow. But we're probably going to join the Ninja Monkeys for their brainstorming, because our kids have no idea how to brainstorm.
Oh, that's all right. Well, and we'll do. I think Gordon Cooper's planning on a brainstorming session, and everybody's invited.
To that.
It's not that funny, but you guys are more than welcome to participate with that. We usually get 4. I think last year we had 8 or 9 teams that came out, and they'll do it. I think it's going to be like a Monday or Tuesday evening, something like that. Roger Ferris will know tomorrow at the time and schedule on that. So if you're interested in that, we can let me know, and I'll get you hooked up with him.
Yeah, I'll ask Wade's the head coach. We'll talk about that and see what we're doing. But it's all the kids at MetroTech here, they're all low income kids, so they don't have the some of them, they have trouble even getting to school because a lot of their parents don't. And I'm familiar with that because I'm an associate pastor at Olivet Baptist Church, which is a very low income area, and so we have we're familiar with kids that if we didn't go pick them up, there wouldn't. I know on the football team that they have, it's amazing. You'll have 18 kids on the team, and you'll be lucky if 5 of them will have parents show up to the football game. And I'm going, what parent doesn't show up for his kids' sports activities?
Yeah,
it's sad.
It's hard.
But that's where we come in. Our opportunity to make a difference in these kids' lives is a privilege, really. Hopefully we can break the generational mold, that exists year after year. We can make this generation different. So that's my.
All right. Well,
thanks a lot. I really appreciate you're willing to take the time to do this. And so anyway, I will.
No problem.
See you tomorrow, right?
All right. Sounds good.
Okay. Bless you. Bye-bye.
You guys take care and drive safe.
Thanks.
All right. One last call for questions or comments before I log off myself. All right, everyone. Safe travels tomorrow, and hope to see you at competition. Take care.